What? Your voices are very low. You are not audible to me. Can you hear me?
I can hear you.
Actually, you both are not audible. I know you are speaking, but you are not audible. Your voice is too low. Okay, anyway. So in this lecture, we are going to start the vector algebra. All right. Okay, so Oshi, tell me what do you mean by vector quantity?
Something that has a magnitude and a direction and follows the vector law of addition.
That has a magnitude and
Direction and follows the vector law of addition.
okay, just a second. Okay, tell me, Shamwon, what do you mean by vector quantity? Do you know what is a vector? Do you know what is a vector? You are not audible. Still, you are not audible. Is this problem is from your side or it is from the? Let me check.
Hello, hello.
Yeah, now you are audible.
Yeah. Vector quantity is anything that has uh, magnitude and direction.
Magnitude and direction. So, vector is something that has a magnitude and had a direction. Magnitude and direction, right? So, can you tell me an example of vector quantity? Can you tell me the example of any vector quantity? Oshi, tell me.
Distance,
Even you,
velocity,
can you repeat, please? What you said?
distance,
Distance. No, distance is not a vector quantity.
displacement,
Displacement. What else?
um, velocity,
Velocity. Anything else? Or कुछ quantities? Okay, just leave it. So vector is basically a quantity that has both magnitude as well as direction. So we know we have a two type of quantities. One is a scalar and one is a vector. So a scalar one is a quantity that has only the magnitude. Like, have you seen someone saying uh 40 minutes in this direction or 40 minutes in this direction, like 40 minutes 40 minute in x-axis and 40 minute in y-axis, something like this? No, because 40 minute is what? 40 minute is a scalar quantity, time is a scalar. Like if I'm saying 40 minutes, so this is what? This is a scalar quantity. It is having only the magnitude, no direction. I'm writing this magnitude in a short, like mag. Okay, I hope you understood this. So this is a magnitude. The scalar one is the only magnitude, and the vector is a part. Vector is having both magnitude as well as direction. So this is the basic of a vector, right? Now there is a term known as a position vector. Position vector. So what do you mean? You know what is a vector. So what do you mean by position vector? Can anyone tell me? Anyone? What is a position vector? किसी को पता है?
Basically, that shows the location, like direction,
What?
location. That shows the location of
Location of what?
the vector. Okay, like the like for example, displacement or like velocity.
No, not location of not a vector. Basically, position vector is a vector. Like let's suppose you have a point. Let's suppose you have this point. This is a point, and in this chapter, when we have to deal with some points, so we have to take three-dimensional. Like we must have x, y, and z point. So let's suppose this is a point in a x, y, z direction, x, y, z plane. That is also known as your Argand plane. So, or you can say the Cartesian plane. So now, position vector is basically a vector that joins the origin to the point in your Cartesian plane. So if you want to find the direction of this, if you want to find the position of this point P in your plane, so position vectors basically tells us about that thing, that where your point is located in a Cartesian plane. Like this is my point, and if I want to denote this by this, this is let's say this is O, that is 0 comma 0 comma 0, that is your origin, and this is a P point. So you are moving from this point to this point. Let's say, okay, you are moving from O point to P point. You know that that position vectors tells you about the position of your point. So this is a point, P point. You want to know the location of this point in a Cartesian plane. So basically, position vector tells you about position of a point with respect to origin, and vector like here I should write OP vector, and this is x I cap plus y j cap plus z k cap. All right. So can you tell me, is there is any difference in OP vector and PO vector? Is there is any difference between both the vectors, OP vector and PO vector? Anyone?
Yes, the direction.
What is the difference?
The direction.
The direction. Okay. So what is the physical reference of this right? What is the purpose of writing this OP vector and a PO vector? What do you understand by this? Let's say you have 2 points, O point and P point. So what do you understand by if I'm writing OP vector and PO vector?
OP is from O to P and PO is from P to O.
Yeah. So basically the physical reference is the physical meaning of this. Like if you are writing OP vector, so that means you have moved from O point to P point. And if you have wrote PO vector, so in that case, this is the direction. Okay. So this is very important. And this is also the negative of this vector. We will deal with this type of vectors in the upcoming presentations. So this is a OP vector, which is minus of PO vector. And this is also known as the negative of a vector. Okay. This is a negative of your vector. So this is how we represent any vector in opposite direction. All right. So we have a two terms. One is a vector, one is a magnitude and one is a direction. So this was some basic thing about the vector quantity. Now let's come to the vector having a magnitude as well as direction, specifically on the magnitude part. So what do you mean by magnitude? Like in this direction, do you understand why I have written x I cap, y j cap, and z k cap? What do you mean by this? Okay, both of you comfortable in Hindi also?
Yeah,
Shamun, where are you from?
I'm from Karnataka.
Karnataka, okay. And Oshi, you are from?
I'm from Bangladesh. I'm fine with Hindi.
Okay, okay. So both of you are fine with Hindi, okay. So what do you mean by this x I cap? Can anyone tell me? जब मैंने यहाँ पे x I cap लिखा तो उससे आपको क्या समझ आया?
X is in the I direction.
Yes, very good.
That is.
That means we have moved x distance in I direction. And what is I? Okay. First of all, I should write this that yes, this I cap is the x axis, the x direction. This j cap is in y direction, and this k cap is in z direction. Okay. So I have written x I cap. That means you have moved x distance in x direction. And similarly, y, that means you have moved y distance in y direction and z distance in z direction. अगर यहाँ पे आप कुछ और लेना चाहोगे ए बी सी तो वो भी बेटर है. इसका मतलब ये हुआ, अगर मान लीजिए मेरी इक्वेशन ये है ए आई कैप प्लस बी जे कैप प्लस सी के कैप. लेट्स से दिस इज माय इक्वेशन. सो इट्स मी its meaning is like, let's say this is a y axis. Okay, this is a y axis, this is a x axis, and this is a z axis. इसका मतलब ये हुआ आप, एंड दिस इज ओरिजिन है ना, ये ओरिजिन है. मैंने इनको अलग अलग करके बता रहा हूँ ताकि आपको थोड़ा बेहतर समझ आए. ओके. सो लेट्स से यू हैव मूव्ड टिल दिस पॉइंट. यहाँ से आपने मूव किया यहाँ तक, दैट इज योर बी. यहाँ से मूव किया यहाँ तक, दैट इज योर ए, एक्स डायरेक्शन. This is z direction, and you have moved this much apart in a on a z axis. That is your C, and this is your B. So this is a basically the reference of this point, R vector. All right. Is it clear?
Yes.
Yes.
Okay. All right. Let's say this is this is a distance. This is some point P in this plane. This is your x-axis. This is y, and this is z. And this is, let's say, this is a P point, x comma y comma z, and this is my origin. That is 0 comma 0 comma 0. Okay. All right. So if I draw a line, this line, this is my origin, this is a point in a 3D plane. So what is a magnitude? Magnitude is basically the distance of your point. मैंने अगर यहाँ पे ओपी वेक्टर लिखा है, मैग्नीट्यूड हम ऐसे रिप्रेजेंट करते हैं मैग्नीट्यूड को, लाइक इफ आई फाइंड द वैल्यू ऑफ मैग्नीट्यूड, so that mean we know magnitude is what? It is the distance from the origin, right? Is it clear? मैग्नीट्यूड डिस्टेंस होता है और origin से. Because
Sure.
see here, what is a magnitude? You have written this x I cap. इसमें क्या होता है? Your x is a magnitude and your I cap is a direction. That combined, in a combined form, it is showing that you have moved x distance in a x axis, that mean in a I cap direction. So it is a combination of a distance and direction. So similarly, your magnitude is what? Your magnitude is a distance, that how much you have traveled in that path. So basically, if you have OP vector, so distance is how you should calculate this. This is the distance. This is the distance. So you can use the distance formula. This is a P point and this is O point. You can use the distance formula to find the distance between both the points. And this will give you the magnitude of what? Tell me, what do you, magnitude of
P
what?
P
Anyone?
magnitude of OP.
Magnitude of OP vector. Okay. All right. So this is a magnitude. Okay. Now let's do a question. Let's do some question on this. Let's say you have a vector, AB vector. So find the direction, find the magnitude of AB vector. Or if you are writing this magnitude, so no need to write this modulus sign. Just write magnitude of AB vector. Find this magnitude of AB vector. Then after doing this, find the magnitude of this vector. Just do these questions. हो जाएगा? Can you do?
Yes.
Tell me, can you do these questions?
Yes.
Shahmun, you are giving a thumbs up. Is there is any issue with your mic, Shambun?
No.
Okay, okay. So why are you hesitating in answering? All right. Do these questions and tell me when you are done. Is it done?
Yes.
Is it done? Oshi, is it done? Yes. Okay. What's the answer? What's the answer for the first question? I think you are unable to hear. Yeah, I'm unable to hear. Your voice is not audible. Am I audible? Please check your mic. Shambun, am I audible?
Yeah.
Tell me the answer.
Is the first one's answer root of 344?
First one is under root of
344,
344, and the second one
root of 432.
432. Okay, nice. Okay. And what's your answer, Shambun? Is the answer is same? Shambun, is the answer is same?
Oh, just give me a minute.
Okay, have a minute.
First one's answer, I got root of 444.
First one you got root of 444, and the second one what's for the second one? Shambun, what's the second one? You're not audible. Can you open your camera if you're comfortable? It is totally fine. There is no need to hesitate. It is better if I can see your face expressions. No? No answers? All right. See, in the first question, you have to find the magnitude of AB, that is a AB vector and its magnitude. So, you know, this is a basically you have to use the distance formula. So, this is 14 minus 0 square, that is 14 square, 12 square, and 2 square. So, this will give you what is 14 square? It's 576. What is 12 square? It's 144. And what is 2? 2 square, it's 4. So when you will add these things, so you are going to have 576 plus
It's
144.
196. 14 square is 196.
Oh, sorry. I thought it was 24. Sorry. 196. Thank you for the correction. 196. Okay. The next solution is running in my mind. That's why. In which I think you might have made a mistake. So this is 196. 1 4 344. All right. So this is the right. Okay. चलिए ठीक है फिर Shamun, you got the wrong answer. This is not the answer. 344 is the right one. Okay.
Yeah, okay. Sorry, I disconnected. Huh?
Am I audible? Am I audible?
Yeah.
Yes.
Okay. Just a minute. Is it visible now? Screen is visible.
Yeah.
Tell me, is it visible?
Yes.
So in the second part, this is a 24 I cap, and since you do not have any J cap term, so you can write this as a 0 J cap. And for the 12 K cap, you have as it is. Now you have to find the AC modulus, magnitude of AC vector. So this will give you under the root. What is the 24 square? 576 plus 0 square is 0 plus 12 square is 144. So 576 plus 144, 0, 5, 7. So this is 750 units. All right. Is it clear now? So this is not the right answer. Okay.
No, but
You should check that
in the one that you wrote, it's 12 ICAP, not 24 ICAP.
in the,
You wrote
I
AC
wrote 12 I cap.
yeah.
Okay. Please check it again. This is 12 I cap and this is also 12 I cap. It is not a J cap, right? कुछ डाउट है यहाँ पे?
Okay. I did not say that.
But you have to see, you have to see this also. So this is this was the I cap. This is not a J cap. So you should add these like terms, and for that you have to at least check. So this is not a J cap. This is I cap. So I cap. You have to add these things, and this is what 24 I cap, 0 J cap, and 12 K cap. And this will give you the magnitude of your AC vector. So this is the magnitude of any vector. Now this magnitude is done. Now we have a direction. Let's say if I want to find the direction, we know this formula. We know this formula. This is if I have a vector, so I can write this as a magnitude of a vector into a cap. This a modulus of a vector is giving me the magnitude, and this a cap is basically telling the direction. So we know this is my vector quantity, And we also know that vector quantity is made up of magnitude as well as direction. So this is a important formula. Whenever I ask you to find uh, the direction of any vector, so you have to find this a cap. Okay, you have to find this a cap. This is basically the direction. And how you will find this? Your a cap will be vector a divided by its magnitude. So whenever it is asked to find the direction of any vector quantity, so you should use this formula. Using this formula, you can get the vector, you can get the direction of your vector quantity. Okay, is it clear? Is it clear? Koshi and Shamun, is it clear?
Yes.
Yes.
Okay, so let's do an example on this. You have to solve this question. Like if I give you any example, let's say this is my vector A, that is 2 I cap, and 2 I cap plus 3 J cap plus 2 K cap. Okay, let's say this is my vector. All right, this is my vector 2 I cap plus 3 J cap plus 2 K cap. If I ask you that tell me the direction of this vector, give me the direction. What is the direction of this vector? So can you find the direction of this vector? We already know how to calculate the magnitude of any vector. Just in the above examples, we already have learned about how to calculate the magnitude of any vector. So I guess, I hope that you can find the direction of this vector. Eventually, you have to find the magnitude also, because that will be used in this formula. All right, do this question and tell me. Is it done?
Yes.
Yes.
Oh, she's okay. Okay,
Hmm.
tell me answer. Shamun, tell me the answer.
7 by root 17.
7 by root.
Or like 2 by root 17, 3 by root 17, and again 2 by root 17.
7 by root 17, 2 by root 17.
No, not 7 by root 7. It's 2 by root 17, 3 by root 17, and 2 by root 17 again.
So how you will write this answer? In this form? This is not the correct format.
Like 2 I cap by root 17, is it like that?
Yeah.
3 j cap and 2 k cap.
All right, good. Okay, so this is the right answer. Are you getting the same answer, Oshi?
Yes.
Okay, good. So this is how you can find the direction of any vector. Okay, direction of any vector. Now you know how to find the magnitude of this vector and how to find the direction of this vector. Okay. Now can you construct a vector quantity if you know what is the direction and if you know what is the direction and what is the magnitude of this that vector? Okay, just tell me this answer. Uh, this is your B cap. B cap means you must have any vector B vector and whose direction is this. So can you tell me what was your B vector?
Four I cap plus 4 j cap plus 4 k cap.
Anything else? Four I cap plus four J cap plus four K cap. Oshi, is it right? Oshi, tell me, is it correct?
Yeah.
देखिए, first of all, if you want to find this, so first of all, you have to find the magnitude of this. And you have seen in your B cap, you have a uniform denominator, that means a root of 48. So you have to check whether 4 square, 4 square, 4 square, sum of 4 squares is getting a 48 or not. So 16 plus 16 plus 16, we're getting 48. So your magnitude is 48, that is okay. Under root 48, that is okay. And it is also present here. So, and you know how to find the B vector. So from there, you can find your B vector. B vector is basically this into B cap. You can find from this. All right. So now this is a basic examples of how to find the magnitude and how to find the direction of any vector. Now we have a type of vectors. The first one is a zero vector. The first one is zero vector. That means if I suppose this point, this is my point. Let's say this is my A point. And in this vector, you do not move in any direction, in any particular direction. Okay, so this is your zero vector. That means you have to start from this point and you have to be on this point only. You cannot move in any direction. Do not move in any particular direction. So that will give you a zero vector. And how you will represent this vector? This is basically a vector. Like we know how to write this in a minus a. हम इस फॉर्म में लिखते हैं ना इसको. So a minus is what? It is zero vector. All right. Or it is more preferred to write in this OA form, because OA is basically the position vector of a point. So this is more preferable to write. All right. So this is the zero vector. And what is the magnitude of this vector? Magnitude is zero. Obviously, this is a zero vector. So magnitude will be zero. Okay. Now you have the second vector, that is unit vector. So as the name suggests, it is a unit vector. What do you mean by unit vector? Anyone? Anyone tell me, what do you mean by unit vector?
Something that has I cap, J cap, or K cap, and it's like coefficient is 1.
Coefficient is 1. No, it is not necessary to have only one coefficient. ऐसा भी वेक्टर हो सकता है जो जिसका coefficient 1 हो. And basically, if you have one coefficient, so that doesn't mean you have a unit vector. Unit vector is what? That has a one magnitude, whose magnitude is 1. Whose magnitude is 1. All right. Let's say you have this vector. You know what is the formula of magnitude? Magnitude is a vector divided by its direction. Right. So if you have this magnitude as a 1, so that means your a vector and your unit vector must be same. So you can assume any examples, like you can have I cap plus 2 j cap plus k cap. 1 square is 1, 2 square is 4, 1 plus 5, 5 plus 1, 6. Under root of 6, under root of 6, under the root of 6. So when you will find magnitude of this vector, आप जब इसका, let's say this is your a vector. When you will find the magnitude of this vector a, so what you are going to have? You have 1 square upon 6, that is 1 square upon under root 6 ka whole square, and 2, that is 4 upon 6, 1 upon 6. When you will simplify this, you are going to have 1. So it is not necessary that each and every component of your x-axis, y-axis and z-axis is a 1, 1, 1. अगर 1 होगा तो obviously that will give you 3 magnitude, right? So in these type of vectors, where your vector is in the same direction of a unit vector, so that will give you a unit vector. And remember this, magnitude of unit vector is always 1. This is the most important thing about this, that magnitude is always 1. This is the only important thing that is you have to remember in this unit vector, that magnitude is always 1. Is it fine?
Yes.
Is it clear? Okay, do you have any doubt? Oshi and Shamun, do you have any doubts?
No.
Please ask your doubts if you have. Okay,
No.
Shamun, what about you? Is it clear? All clear?
No. Yeah.
Okay. Okay, so that's all for today's class. And in the next class, hopefully we will start with the next topics of these vectors, basically the addition of vectors. Okay. Okay, so thank you for the class. Love is.
Thank you, Allah Hafiz.